Your Ford F-150 is actively tearing itself apart from the inside out, and it is happening because of the exact factory settings Ford programmed into it to meet federal mandates. You buy a $60,000 truck expecting it to last 200,000 miles, but right now, hidden computer algorithms and default parameters are quietly cooking your oil, grinding your engine bearings to dust, and laying the groundwork for a $7,000 transmission replacement. Most owners have no idea this is happening because the dashboard gauges are literally programmed to lie to you until the damage is already done. I have spent decades in the shop tearing down these components, pulling oil samples, and inspecting failed rod bearings with my own hands. I see the exact same preventable carnage on my lift week after week. Today, I am exposing 5 factory settings and features in your F150 that are causing hidden, cumulative damage without you knowing. Setting number 3 has caused more silent powertrain wear in modern EcoBoost and V8 trucks than almost any other software routine. And setting number 1 is so deceptive that millions of owners actually think it is a feature designed to protect their vehicle, when in reality, it is doing the exact opposite. Let's get into it. Setting 5. The Factory Intelligent Oil Life Monitor. Ford markets this feature as a sophisticated, worry-free system that analyzes your driving habits, ambient temperatures, and engine loads to calculate the exact moment you need an oil change. On paper, it sounds like modern engineering at its finest. The system will routinely allow you to drive 7,500, 10,000, or even 10,000 plus miles before throwing a warning light on your dash. But here is what Ford doesn't tell you. That algorithm is optimized to pass federal low cost of ownership metrics and fleet sales targets, not to make your engine live to 200,000 miles. Here is the hidden mechanical reality. In a direct injection engine like the 3.5L or 2.7L EcoBoost, and even the 5.0L Coyote, fuel dilution is an absolute reality. Raw gasoline washes down the cylinder walls during cold starts and under high boost, mixing directly with your engine oil. By 5,000 miles, that oil is no longer operating at a true 5W30 viscosity. It has been sheared down by high turbocharger temperatures, which hit well over 1,000 degrees Fahrenheit, and diluted by unburnt fuel. At 8,000 or 10,000 miles, your oil is stripped of its anti-wear additives, its viscosity is destroyed, and it is holding suspended carbon particles in circulation. That degraded fluid is starving your timing chains, phasers, and main bearings for protection. The timing chain links begin to wear at the pin joints, creating the classic timing chain stretch and rattle that costs over $3,000 to fix. You think you are saving $50 by extending your service interval, but you are actually grinding your engine's precision components to dust. What you should do instead is completely ignore the digital percentage on your dash. Never let an F-150 go past 5,000 miles or 6 months on an oil change, whichever comes first. If you tow regularly or live in a severe cold climate, drop that interval to 3,000 to 4,000 miles. Use a high-quality full synthetic fluid that meets Ford's latest WSS-M2C961-A1 specification and replace the filter every single time. A $50 oil change every 5,000 miles is the single cheapest insurance policy you will ever buy for your truck. Setting 4 is one that Ford markets as a seamless, fuel-saving feature, but under specific conditions, it is creating the exact environment that destroys your engine's bottom end. The Auto Start-Stop default setting. Every time you turn the key or push the start button in a modern F-150, the truck defaults to Auto Start-Stop engaged. Ford claims this system saves you fuel at stoplights and reduces idle emissions. What they omit from the glossy sales brochure is what happens inside the engine block every single time that engine shuts off and restarts at a traffic light. To understand the damage, you have to look at fluid dynamics and bearing clearances. Your crankshaft floats on a microscopic film of oil, roughly 0.001 to 0.002 inches thick, pressurized by the mechanical oil pump driven off the front of the crankshaft. When the engine stops at a light, that oil pressure drops to absolute zero instantaneously. The heavy crankshaft settles down onto the main and rod bearings, squeezing out that protective oil film. When the traffic light turns green and the starter motor cranks the engine back to life, those metal surfaces experience hydrodynamic boundary friction, meaning metal-on-metal contact, for several critical fractions of a second, before oil pressure can re-establish itself. A normal engine without auto start-stop might experience 50,000 to 100,000 start cycles over its entire lifespan. An F-150 with auto start-stop enabled undergoes up to 500,000 start cycles in that same time frame. I have personally inspected rod bearings pulled from 80,000-mile engines where the protective polymer coating on the upper bearing shells was completely wiped clean down to the copper substrate. You are subjecting your engine to daily microscopic wear, cooking your starter motor, and cycling your battery to save a fraction of a gallon of gas per tank. The solution is simple and costs you nothing. Make it a muscle memory habit to press the Auto Start-Stop Disable button on your dash the moment you start your truck. If you don't want to press the button every time you hit the road, you can install an inexpensive plug-and-play Auto Start-Stop Eliminator harness behind the switch that remembers your preference permanently without voiding your warranty or altering your PCM code. Now that we have exposed how Ford's program service intervals and start-stop routines are quietly wearing down your engine from the top and bottom, it is time to look at the drive system algorithms that are actively destroying your transmission and driveline. Setting 3. The default skip-shift control strategy. When you drop your 10-speed F-150 into drive and roll away from a stop sign under normal acceleration, pay close attention to the gear indicator on your instrument cluster. You will notice the transmission does not shift 1, 2, 3, 4, 5. Instead, Ford programmed the transmission control module to skip gears routinely, often launching in first, slamming straight into third, hopping to fifth, and jumping directly to seventh under light throttle. Ford markets this skip-shift strategy as a modern feature designed to deliver seamless, car-like acceleration while keeping fuel economy numbers artificially inflated for government testing. Here is the hidden mechanical reality that I see on the teardown bench every single week. To execute a smooth skip shift under load, the 10R80 transmission cannot simply swap ratios passively. It has to slip multi-plate clutch packs rapidly while modulating line pressure through hypersensitive hydraulic solenoid valves to catch the next high ratio smoothly. When jumping from first to third or third to fifth, the transmission forces specific clutch packs, specifically the CDF clutch drum assembly in earlier 10-speed models, to absorb massive torque spikes and thermal friction in a split second. This constant slip-and-catch strategy generates extreme localized heat right at the friction material surfaces. Over time, that thermal cycling causes the internal Teflon bushings inside the CDF clutch cylinder to migrate out of position. Once that bushing moves, it uncovers oil feed passages, causing a sudden loss of hydraulic pressure. That pressure drop leads to severe gear harshness, violent shift flares, erratic hesitation, and eventually complete clutch pack destruction. You think your truck is just being smart and efficient, but in reality, every skipped gear under load is dragging friction discs and cooking the hydraulic control circuit. What you should do instead is bypass this skip-shift routine entirely whenever you drive. You do not need to buy an expensive tuner to do this. Simply press your drive mode button and switch the truck into tow/haul mode or sport mode as soon as you start driving. Both of these factory drive modes overwrite the aggressive skip-shift algorithm, forcing the transmission control module to run through all 10 gears sequentially, 1, 2, 3, 4, 5, and so on. Sequential shifting distributes the friction work evenly across all internal clutch elements, drastically reduces hydraulic shock, prevents thermal hotspotting, and keeps your transmission fluid dozens of degrees cooler during stop-and-go driving. Setting 2 is a feature that Ford markets as a convenience and efficiency marvel, but under real-world conditions, it is actively causing severe thermal breakdown and micro-welding in your drivetrain. The factory 150,000-mile transmission fluid service interval and default low-pressure thermal bypass valve. Ford states right in your owner's manual that the Mercon ULV transmission fluid in your 10-speed or 6-speed automatic is a fill-for-life fluid that does not require its first service until 150,000 miles. To complement this extended service claim, Ford equips these transmissions with an internal thermal bypass valve calibrated to keep transmission fluid operating at an ultra-high baseline temperature, often between 205 and 220 degrees Fahrenheit, before allowing it to flow to the external cooler. Ford tells you this elevated temperature reduces fluid drag, maximizes fuel economy, and makes servicing almost non-existent for the first owner. Here is what Ford leaves out of the manual. Automatic transmission fluid is a complex blend of base oils and chemical additives designed to lubricate gear sets, maintain hydraulic pressure, and protect delicate valve body solenoids. As a rule of chemistry, every 20 Fahrenheit increase in fluid operating temperature above 175 degrees cuts the effective chemical life of that lubricant in half. Running your transmission at 215 degrees on a daily basis causes the Mercon ULV fluid to oxidize, break down, and varnish at an accelerated rate. By 50,000 miles, one-third of Ford's recommended interval, that fluid has lost its shear stability and is contaminated with microscopic clutch material and metalware particles, shedding off the planetary gear sets. That contaminated fluid flows directly through the tiny, microscopic tolerances of the main valve body casting. The solenoid valves begin to stick, the bore wear accelerates, and the torque converter clutch friction material begins to slip, causing that infamous shudder between 40 and 50 miles per hour. Waiting until 150,000 miles to service your transmission fluid is guaranteed mechanical suicide. By the time you reach that mileage, the valve body is scored beyond repair, and the clutch packs are completely burnt. What you should do instead is discard Ford's 150,000-mile schedule immediately. Drain and refill your transmission fluid, and replace the internal pan filter every 30,000 to 45,000 miles without exception. Never perform a high-pressure flush on a high-mileage unit. A simple pan drop, filter swap, and refill with genuine spec fluid is all it takes. Furthermore, if you tow heavy loads regularly, consider having a reputable shop install an aftermarket thermal bypass valve kit or low-temp thermostat update, which opens fluid flow to the external cooler at 160 to 170 degrees Fahrenheit instead of 210 degrees. Keeping your fluid clean and operating under 190 degrees will instantly double the physical lifespan of your transmission components. We have covered the maintenance traps, the start-stop wear, the skip-shift destruction, and the fluid thermal decay. That brings us to setting number 1, the single most deceptive factory setup programmed into your truck's instrument cluster. Setting 1, the programmed dummy gauges and factory oil pressure sensor switch. Look at your F-150's dashboard right now. Right above the digital center screen or flanking the tachometer, you have physical needles or digital bar graphs for engine oil pressure, coolant temperature, and transmission fluid temperature. Ford markets this fully loaded cluster as a professional monitoring suite, giving you complete real-time insight into your engine and drivetrain health while towing or driving hard. They want you to believe that if a mechanical parameter strays outside safe limits, that needle will move, giving you ample warning to pull over before catastrophic failure occurs. Here is the absolute reality that leaves owners stranded on the side of the highway with a blown engine. Those gauges are not real-time physical instruments. They are computer-simulated dummy displays running on sanitized software routines designed specifically to keep you from complaining to the dealership during the warranty period. Take your engine oil pressure gauge, for example. On almost every modern F-150, there is no real-time variable oil pressure sending unit sending an actual analog voltage to the dash. Instead, Ford installs a cheap, binary $8 pressure switch on the engine block. That switch is calibrated to close at roughly 5 to 7 pounds per square inch of pressure. If your engine is producing 6 psi of oil pressure at 2,000 RPM under load, an appalling condition that is actively grinding your main bearings, rod journals, and camshaft lobes to metal shavings, that pressure switch closes, tells the engine computer everything is fine, and the computer commands the needle on your dashboard to sit dead center in the normal range. The needle stays locked squarely in the middle, whether your engine has 15 psi or 80 psi. It will not drop to zero or flash a red warning light until oil pressure plunges below 5 pounds per square inch, at which point your bearings are already melted and your engine is destroyed. The exact same deception applies to the coolant temperature display. The gauge software applies a massive dampening curve, a dead zone, between roughly 170 and 230 degrees Fahrenheit. The needle sits at the exact same middle spot, whether your engine is running at a happy 190 degrees or climbing into a dangerous 228-degree heat-soak condition on a mountain pass. By the time that needle finally swings toward the red zone and flashes a hot engine warning, Your cylinder heads have already warped, your head gaskets have blown, and your turbos have baked their internal oil lines into carbon sludge. What you should do instead is stop trusting Ford's factory dashboard needles to tell you the truth about your truck's health. If you tow regularly, carry heavy payloads, or plan on keeping your F-150 past 100,000 miles, invest in a dedicated OBD2 digital monitor or scan tool interface, such as an Edge Insight, an N-Gauge, or an inexpensive Bluetooth OBD2 adapter paired with a tablet running real-time monitoring software like Torque Pro. By pulling live data directly from the engine control module's actual sensor PIDs, you can monitor true digital coolant temperatures, true transmission fluid pan temperatures, boost pressures, and cylinder head temperatures in real time. Seeing your coolant creep from 200 to 220 degrees long before the factory dashboard needle even twitches gives you the exact window of opportunity you need to drop down a gear, back off the throttle, and protect your engine long before permanent damage occurs. When you step back and look at the whole picture, a clear pattern emerges. Your F-150 was engineered by brilliant technicians, but its factory software settings were dictated by corporate fuel economy standards, low advertised cost of ownership metrics, and warranty period risk management. Ford designed these default parameters to get the truck past its 60,000-mile powertrain warranty with glowing review scores, not to ensure it reaches 250,000 miles in your driveway. The good news is that you are no longer at the mercy of those hidden factory settings. By taking back control, changing your oil every 5,000 miles, disabling auto start-stop every time you turn the key, running tow/haul mode to stop the destructive skip-shift routine, servicing your transmission fluid every 30,000 to 45,000 miles, and monitoring real-time digital engine parameters, you eliminate the silent wear mechanisms that claim thousands of trucks every single year. You paid hard-earned money for your vehicle, and with a few simple operational shifts and disciplined maintenance habits, you can outsmart the factory programming, save yourself thousands of dollars in catastrophic repair bills, and keep your truck running reliably for as long as you choose to own it. If you want to stay ahead of hidden manufacturer faults and protect your investment with real-world technical breakdowns from the shop floor, make sure to hit that like button, subscribe to the channel, and drop a comment